This video we will talk about solving exponential equations without using logarithms. We've previously learned that we can solve exponential equations by using logarithms. However, sometimes we can convert the powers so that they each have like bases, and then the process is much simpler. When determining the base to use in such circumstances, think small. And you'll see what I mean as we get into it. So here's our first example. Solve for x. The equation is 3 to the exponent x minus 1 equals 9. Well, rather than trying to convert 3 into a base of 9, let's convert 9 into a base of 3. And that's what I meant when I said think small. So let's convert each side to a base of 3. We know 9 is equal to 3 to the exponent 2, and we don't even have to convert on the left-hand side, so we get 3 to the x minus 1 equals 3 to the 2. Now that we have both sides of the equation written entirely as a power of 3, we can ignore the 3's and just solve the equation. So ignoring the 3's, we see x minus 1 equals 2, and therefore x equals 3. Here's another question. Solve for x where 2 to the 3x plus 4 equals 8 to the 2x. Well, we can convert 2 and 8 to powers of 2. So on the left-hand side, we're not doing any changes, 2 to the 3x plus 4. But we can convert 8 to 2 to the exponent 3. So instead of 8 to the 2x, we have 2 to the exponent 3 to the 2x. Well, when we raise a power to another exponent, we multiply the exponents. So we can say 2 to the 3x plus 4 equals 2 to the 6x, because 3 times 2x is 6x. Now that left side and right side are both entirely written as powers of 2, we can ignore those 2's and just set the exponents equal to each other. 3x plus 4 equals 6x, meaning 4 equals 3x, meaning x equals 4 over 3. In the next question, we'll solve for x where 125 to the exponent x minus 3 equals 25 to the exponent 4x minus 5. Well, we can convert 125 to 5 to the exponent 3, and we can convert 25 to 5 to the exponent 2. So 5 to the exponent 3 to the x minus 3 equals 5 to the exponent 2 to the 4x minus 5. And now we have a power raised to another exponent, so we multiply the exponents. 3 times x minus 3 is 3x minus 9. Same thing on this side, 2 times 4x minus 5 is 8x minus 10. Now we're entirely a power of 5 on both sides, so we can ignore the 5's. Say 3x minus 9 equals 8x minus 10. Add 10 to both sides and subtract 3 from both sides. We get 1 equals 5x, meaning x equals 1 over 5. Here we're going to solve for x where the cubed root of 4 raised to the exponent negative 5 equals 1 over 4 to the exponent 6x minus 7. Well, the cubed root of 4 can be written as 4 to the 1/3. And I want to get everything in exponential form. 1 over 4 to the 6x minus 7 can be written as 4 to the 6x minus 7 to the exponent negative 1. And this way I've got each side written entirely as a power of 4. I can multiply these exponents, and I can multiply these exponents. Ignoring the 4's, I can say negative 5/3 equals negative 6x plus 7. Add 6x to both sides and add 5/3 to both sides, and I get this equation right here. Converting 7 to 21 over 3, I get 6x equals 26 over 3, meaning x equals 26 over 18, and I can reduce that fraction to 13 over 9. A couple more questions here. Let's solve for x where 7 to the exponent 5x plus 8 equals 1. Well, we learned that 1 can be any base to the exponent 0, with the exception of 0 to the 0, which hardly ever shows up. So since the convenient base for me to use is a base of 7, I'll re-express 1 as 7 to the exponent 0. Now I can say 5x plus 8 equals 0. Subtracting 8 from both sides and dividing by 5, I get x equals negative 8/5. And finally, here's a dandy question to end on. We're going to solve for x where 9 to the exponent 2x minus 4 times 27 to the exponent 3x plus 2 equals 81 to the exponent 55. You might remember at the start I said think small. Let's think of 9 and 27 and 81 each as powers of 3. So 9 is 3 squared to the exponent 2x minus 4. 27 is 3 cubed to the exponent 3x plus 2. And 81 is 3 to the 4 to the exponent 55. Now I can multiply these exponents. 2 times 2x minus 4 is 4x minus 8. 3 times 3x plus 2 is 9x plus 6. And 4 times 55 is 220. Now I'm multiplying powers with like bases, so I can add the exponents. 4x minus 8 plus 9x plus 6 equals, and then on this side we have 3 to the exponent 220. Now since both sides are powers of 3, I can ignore the, first I can simplify this exponent to be 13x minus 2. And now since I've got each side expressed as a power of 3, I can ignore those 3's and just write 13x minus 2 equals 220, which means 13x is 222, or x is 222 over 13. And that's it.